Let us discuss a question from heat transfer. So this is a question on lumped heat transfer where you have initially a steel wall where the initial temperature is uniform temperature is 450 and it is placed in an environment where the temperature is 100. So it tries to give out the heat. So lumped analysis assumes that the temperature of the entire body decreases at a time. That means both the inner core as well as the outer surface temperature, there's not much variation and it all decreases at a time. So the initial is T naught is 450, T infinity, which is far away temperature, is 100. Okay, and the convective heat transfer coefficient is given because it gives out heat by convection. It's open air convection in air. So what is asked is the total heat transfer from the sounding after 1.5 hours. So after a time of 1.57 hour, which is 16 to 60 seconds, what is the total heat transfer? Now the total heat transfer which this steel ball gives out for a solid is mass into specific heat into change in temperature. The change in temperature initially is T naught and the final temperature after 1.7 hour is, let's say, T. So this we can find out only when we can get what is the temperature at after 1.7 hour. Everything else is known, mass, specific heat, everything else is known, but temperature is something which we don't know. Now using the lumped heat transfer analysis, the temperature at any time, the ratio of the temperature, ratio of the difference with the ambient at time t2. So this is the difference at time t, this is the difference at time 0, that is related in this way, HA by rho CV into time t. So these are bunch of parameters which you know. H is heat transfer coefficient, A we know 4 pi r square for a sphere, volume, specific heat is C, and rho is density. So here also I have used specific heat C throughout so that we will be consistent, and time is also given. So from this expression we can get temperature at time t, which is this quantity. Substitute on the right side equation and then we get the answer. So we'll first begin with this. Temperature at time t we don't know. T infinity is given as 100. Temperature at T naught is basically 450 and it is 100 here. E power HA by rho CT, H is given as 10. A is, so A by V, how we get A is 4 pi r square and volume is 4 by 3rd pi r cube for a sphere. So A by V is basically 3 by r. Now remember that this is r, so 3 by r is the answer. Okay, so 10 is h, okay, h, and A by V is 3 by r, so r is basically 25 centimeters, so 0.25. We'll substitute everything in meters. Time we know it is 1.7 into 16 to 60. Okay, so we have substituted rho AC by T, and density we know it is given as 8000. Okay, steel's density, and specific heat is 0.46 kilojoules, so 10 power 3 there, and A by V we have replaced is 3 by r, so the volume of it is taken. So we have substituted everything. Now when we solve this we get temperature about 368.8 degrees Celsius. Remember, it's just the ratio that matters here. So 368.68 degrees Celsius is the temperature. So now we know the temperature after time t, and so we can just use this. Mass is again density into volume into specific heat into T naught minus T. So density is given as 8000, volume is 4 by 3rd pi r cube, r is 25.25, 25 centimeters, so 0.25 meters. Specific heat is again 0.46 into 10 power 3, and the temperature at initial was 450, now it is 368.68. So when I solve this I get a bigger thing, I get a 15.25 megajoules. So 15.25 megajoules is the answer for this lumped heat transfer analysis. Thank you.